We are the truly advanced life in the known universe. I mean, envision that we're the key spot where there is data in this limitless system. Cosmologists all throughout the world are in awe of this ever-evolving discovery. The James Webb Space Telescope has captured the faint glow of city lights an incredible 7 trillion miles from Earth, defying all expectations. This astounding achievement does more than broaden our horizons regarding what we know about the universe. Theories are running wild as researchers analyze the data, searching for clues that could unlock the secrets of these bewildering, staggering finds. The thought is astonishing. Could we be following in the steps of other extraordinary beings in the universe? Is it possible that the universe is teeming with life and advancement far beyond our understanding? Could these faraway lights indicate the existence of extraterrestrial civilizations? What does this mean for our understanding of the probability of life beyond Earth? Join us as we examine how the James Webb Telescope just observed city lights 7 trillion miles away. Launched into space on Christmas Day 2021, the James Webb Space Telescope, JWST, was designed to surpass the highly regarded Hubble telescope by capturing extraordinarily sharp images of newly discovered phenomena, planetary structures, and more. A primary goal of the JWST is to study the formation of the earliest galaxies by examining the farthest reaches of the universe. This is possible because the travel time of light across our universe spans billions of years. When the JWST captures light, it sees these objects as they were billions of years ago. Astronomers measure distances in light years, which represent how far light travels in a year. To illustrate, the mission's first significant achievement was a deep-field image unveiled on July 11, 2022, by U.S. President Joseph Biden from the White House. While the Hubble Space Telescope focused on a single region of the sky for 10 straight days starting December 18, 1995, its Hubble Deep Field became famous. That region covered only a tiny spot, about 1/1,000,000th of the entire sky. Most of the 3,000 faint objects captured by Hubble were massive galaxies billions of light-years away. With its focus on the SMACS 0723 galaxy cluster, the JWST Deep Field covers a similarly small sky area. The galaxy cluster SMACS 0723 is 4.6 billion light-years away, and the more distant galaxies behind it are magnified by the immense gravitational field. The bright galaxies are stretched into arcs where the gravitational field is strongest. In one instance, it was confirmed that light from a distant galaxy took 13.1 billion years to reach the telescope, traveling through space. As the universe expands, the light emitted from these objects stretches into the infrared spectrum. The JWST's primary objective is to capture this infrared light from stars. Astronomers can compare JWST's infrared images with visible light photographs of nearby galaxies taken by Hubble and other telescopes. By gathering data at these frequencies, scientists can observe how galaxies have evolved over vast timescales and form the shapes we see today. More remarkable than the sheer number of galaxies in the JWST's first deep field image is how quickly it was captured, in mere hours compared to days or weeks with other telescopes. Wherever it looks, the telescope cannot help but uncover galaxies. Galaxy clusters aren't the only objects acting as gravitational lenses. Astronomers used the JWST to capture an image of two galaxies, labeled VV1191, to study how light from one galaxy changes as it passes through the other. The findings of this study will reveal more about the properties of the intervening galaxy's structure. Furthermore, the JWST may have made a groundbreaking discovery: light from a very distant galaxy. A recent announcement from the official JWST website revealed the possible presence of auroras on an exoplanet. The lack of a host star and the cold temperature make it challenging to determine where the energy in the upper atmosphere is coming from. However, the detection of auroras is significant, especially since this object is producing methane. Auroras on Earth are caused when energetic particles from the Sun are captured by the planet's magnetic field. These charged particles travel through Earth's atmosphere near the poles, colliding with gas particles and creating the brilliant light display known as the aurora borealis. Jupiter and Saturn experience similar auroral phenomena due to the solar wind. But the peculiar object W1935, which lacks a star to orbit, poses a huge mystery. The scientific community's attention continues to focus on Proxima Centauri and TRAPPIST-1, about 4.4 light-years from Earth within the Milky Way galaxy. Experts have even detected the presence of water on some exoplanets, suggesting the tantalizing possibility of life. Exoplanets and the chance of life in the universe can't be blocked. Are we, at long last, going to see proof of life beyond Earth? Simply last month, the JWST, James Webb Space Telescope, observed another uncommonly large black hole. This epic black hole was seen in various frequencies and is consuming everything around it. This discovery is of a black hole 40 million times as wide as the Sun. But what's the significance for us? The JWST has found that this exceptionally massive black hole has existed since the beginning of the universe. This beast is rapidly consuming everything in its vicinity. The discovery was made by Dr. Lucas Fu and Professor Alastair Z of the Ben-Gurion School of the Nia in Israel. According to their findings, this very massive black hole is nearly 1 million times heavier than the Sun, making it an enormous entity. Fortunately, it is located at a vast distance from Earth, around 129 billion light-years away. However, it is drawing closer, consuming everything around it at a rapid pace, as indicated by the redshift. When the JWST began sending back its limited data, researchers were excited. As they analyzed the information received for the Rebels program, 3 small objects with a faint red glow caught their attention. Initially, they believed it was a nearby large black hole. However, when they analyzed the data using gravitational lensing, they discovered something far more fascinating. The observation of similar phenomena in other early universe massive black holes has provided new insights into the formation of both black holes and their host universes, as well as the connection between the two. This connection remains largely unknown, but it could be evidence of the early-stage formation of massive objects like star-forming materials that fell into black holes. Space scientists still can't fully decipher what's happening in the images returned to Earth, but one thing is clear: the James Webb Space Telescope is continually discovering strange new objects. Every day, we have the privilege of exploring space and being captivated by the stunning lights of planets and stars that drift across the universe, light-years away. Not only does the JWST allow us to see far beyond what our eyes can perceive, but it has also revealed a mysterious object in one of its images. This image, which focused on something else, was taken by the European Space Agency while observing 2 young stars about 1.47 light-years from Earth. However, there is a tiny, enigmatic object, an orange mark at the bottom of the image, that seems to resemble a question mark. Interestingly, this small detail is far from trivial. In fact, it is significant. The question mark shape was captured during observations of young stars known as Herbig-Haro objects, which are surrounded by massive rings of gas and dust. Regarding the question mark shape itself, it may simply appear this way due to the 2-dimensional perspective presented by the telescope. At this point, we have no clear understanding of what it is, and without further study we may never know. However, the discovery has been confirmed by experts, and it is possible that it represents a distant structure or perhaps galaxies interacting with each other. The inverted question mark shape could be the result of their gravitational interactions. Given the surge of distant, peculiar structures revealed by the JWST, there is a continuous flow of new and intriguing discoveries. All eyes are now focusing on a particular set of Earth-sized planets that could hold the key to discovering extraterrestrial life. The enduring mystery of why we haven't found evidence of advanced extraterrestrial life, despite the high probability of its existence, could finally be solved. Where are these planets? They are located precisely 40 light-years from Earth in a nearby star system known as TRAPPIST-1. This system contains 7 planets orbiting a small star. In their quest to find habitable planets, NASA is considering a broad range of criteria. Beyond the planet's size and distance from its star, researchers are evaluating the overall conditions of the planet's atmosphere to determine its habitability. The Infrared Spitzer Space Telescope, part of NASA's space exploration mission, discovered the 7 TRAPPIST-1 exoplanets years ago. Now, the James Webb Space Telescope has measured the temperature of TRAPPIST-1b, one of these planets. The JWST has consistently made groundbreaking discoveries since its launch, and this finding is just the latest in a series of historic achievements. This is the first detection of light emitted by an exoplanet as small and cool as those in our solar system. No other telescope has been capable of measuring such faint mid-infrared light. Space scientists were thrilled when they first learned about the 7 TRAPPIST-1 exoplanets because these distant worlds are all Earth-sized and lie in the habitable zone, the region where planets can have liquid water on their surfaces. However, the TRAPPIST-1 planets are currently beyond our reach, located an astonishing 235 trillion miles away. They orbit a star much smaller and redder than our Sun, known as an M-dwarf star. These stars are far more common in the Milky Way than Sun-like stars and are ideal targets for planet hunters. However, M-dwarfs are also more prone to flaring and emitting high-energy radiation, which could harm emerging extraterrestrial life or a planet's atmosphere. When we turn our attention to TRAPPIST-1b, we find that it is tidally locked to its star. One side of the planet is constantly facing the star, while the other remains in perpetual darkness. This temperature difference creates extreme conditions, with the daytime side reaching temperatures hot enough to melt iron, while the dark side remains much cooler, though warm enough to prevent the development of methane, a key atmospheric gas. Although this might reduce the planet's potential for hosting life, the JWST's ability to measure these extreme conditions offers a unique perspective on distant exoplanets and their atmospheres.